Sometimes failure is just success by another name. And today is a pretty good example of that. I thought it'd be fun to make a quick little chroma keying circuit today. And I've sort of got it working. It's not perfect. And I'm sort of debating, do I want to put a lot of effort in to work out why it's not right? And maybe folks in the comments can sort of explain what I'm doing wrong. I'm not an expert. But I'm kind of happy with the results. And I think I might just integrate it as is into the rest of this device. So let me bring you in and show you what I'm doing. The signal I'm currently sending out is just vertical color bars, and I'm using this as the basis of working out my chroma keying circuit. Let's have a look at the scope and you can see what these color bars look like. What we're looking at here is the blue component signal on the oscilloscope. And for each of the color bars, you can see high blue component, low blue component, high blue, and they're alternating back and forth, and that gives you the range of colors you see in the color bar. So chroma keying is about selecting a range of colors or a range of chrominance levels and creating a key signal from that. So a signal that's either on when that color range is present or off when that color range is not present. The way that I'm doing that is using two op amps and basically an AND gate. I'll show you on a circuit diagram what this looks like. Okay, so this is the basic circuit that I've set up for doing the chroma keying. We have our PB component signal coming in, and as you remember from the scope, it looks a little like that for the color bars. There's our 0 volt, it's sometimes positive, sometimes negative. What we're trying to do is select a small range of these values, let's say between here and here, and when the color is in this region, we want to output a high pulse and a low whenever the color bars or the color signal is not in that region. So what I'm doing is I've got the signal going into two op amps, and I'm using these op amps as comparators. Comparators are different from op amps, but you can use them at a pinch like this, and there are some challenges. So I have the first signal going into the non-inverting input. This is the plus side, and the minus side I have going into a voltage divider. I've actually got these at 2 volts here because that's sort of the range of this signal. And so if we just look at this section, let's say that this is currently at this threshold level here. When the signal is above that, this is going to be on. Likewise, I've got it set up here, but in the inverting configuration, when it's going to be below that level, it's going to be on. So this basically sets our upper and lower voltage limits when either of these op amps will be on. Then we go into an AND gate so that when they're both on, we output the key signal. Does that make sense? Hopefully that makes sense. Anyway, the challenges I was having with this circuit is op amps aren't comparators. I was getting a lot of ringing and noise. So, you know, there are capacitors that you put on either side of the power rails to help decouple. Capacitors need a lot of decoupling on these AND gates and all that sort of stuff. But it kind of worked, and it's not the ideal effect, but it's cool and it looks cool, and I'm going to keep on going with it. This is obviously just looking at the PB. Obviously you can have multiple different colors that have the same PB voltage. So what you'd want to do is duplicate this circuit completely with the PR channel and your 2 op amps going into an AND gate, and then AND both of these together, and that would give you a precise color level. But I was just testing the circuit with this by itself and got some cool, neat effects. This is what you saw at the start of this video. And I think I just dropped my mic. So here we have our color bars. I'm sending the key signal out just to the blue so we can turn on and off colors from the blue range. So if we bring our lower voltage level, our upper voltage level down, we can turn off the blue, turn off the magenta, then turn off the cyan. You can see it's not perfect. It's almost as if that blue is sloping. It doesn't look like it on the scope. I think it might be some sort of signal propagation or capacitance issue. But let's see if we can just get the magenta to be on by itself. So we've turned off the blue. Now if we bring up our bottom level, there we go. So we just have the magenta range of the blue signal coming through. It's not perfect. There's lots of weird ringing and noise and whatever, but it's kind of gentle noise. It's not harsh. So I like it. I'm going to go with it and keep on working on this circuit. See you next time. Bye.